Hello everyone, this is Srividya, Assistant Professor, Department of CSIT, Namalar Institute of Technology. In today's session, I am going to teach linear search in C programming. So what is linear search? What is the definition of linear search and what is its working principle, the time complexity of linear search? What are the pros in this, cons, everything we will see in this video. So what is a linear search? A linear search is a simple searching algorithm that checks every element in a list sequentially to find a target value. Suppose there is an array. In that array, we have 10 number of elements. So out of that 10 number of elements, I want to find a specific element, whether that element is present in the list or not. So you can consider that value is a key value. So based on that key value, you are going to search whether that element is present in the list by checking with each and every element in the array. Okay, so linear search is a simple searching algorithm that checks every element in a list sequentially. What is sequentially? Sequentially is nothing but in order. So after when that particular element is compared with the first element in the list, if the element was not found at that position, so the key means whatever the search element you will take, that will move to the next position and it will search with the next element in the list. The working principle: start from the first element in the list. Next, compare the target value with each element in the list one by one. Compare the target. Start from the first element in the list. Suppose, consider this as an array. So this is my array. So what is the number of elements in the array? Total the elements are 7 elements in the array. Suppose I want to search whether 4 is present in the list or not. So I want to search whether 4 is there in the list or not. So that value I'll consider it as the key value. Key value is equals to 4. So I'll search whether that 4 is present in that list or not. So start from the first element in the list. How you will start? You have a key value and you will compare that key value with the first element in the list. And after that, it will move towards next position in the array. Next, compare the target value with each element in the list one by one. When you have the key value and you will start searching from here, this element is compared. Then again, no, both are not same, so that the element here you will move. You will search with this element in the array. If the target is found, return the index. If target is found, so what we need to return? If the target is found, suppose in this case 4 is present at which position you got that element for? At index. The element 4 is found at the index position 4. Element found is at the index 4. So when you found that element, we need to return the index position. So at index 4 you got that element. Otherwise, continue until the end of the list. If the element is not found in the list, suppose again example, now my key value is, here in this case my key value is 4, that I got that element at the position 4. In this case, suppose my key value is 24. Key is equals to 24. So now what I will do? I have the key value and I have this array. So these are my array elements. These are the array elements. So now I will start comparing from the index 0. So 24 is compared with 10 in the array. No, they are not same. Okay. So the next, it will move towards this position. Next, 24 is compared with 12 in the array. So I have the key value 24. Now I'll compare that value with the value that is in the index, which is 12. not same. Again we will move towards the next position 1. Like that it will go to the end of the list. 24 is not there in the list. So what it will return? It will return the element is not found in the list. If the element you got in the list, you should return this. Which one we should get? We should get the index position. In the previous case, my key value is 4 and that key value is present in the index 4. At the position 4, you got that key value. So, the time complexity of the linear search for the best case, it is order of 1. Order of 1 is the best case and average and worst cases are order of n. Order of n. And space complexity is again order of 1. Okay, next one, what are the pros? We'll see after discussing with this algorithm and program. We'll see what are the pros and cons. So this is the brief idea of what a linear search. Linear search is also called as the sequential search, in which we will search the key value with each and every element in the list one by one. If the search element is found, what it should return? It should return the index position. If not, you will get, it should print the element is not found in the list. Until you find that element, you have to go through the end of the list. And the best case is order of 1 if the target is element. If the target element is, suppose if your key value is at the target position, means that it's starting first element is the first element, then the best case will be order of 1. And the average and worst cases are order of n. Let's see with an example. So consider this as your array. So here the array elements I am taking. So this is your array. Okay. So and the name of the array is A and these are your index position. So now let's take the key value is equals to 70. So now my key value here is 70. So what is linear search? The search process starts comparing with each and every element in the list. So now first element is here, first element is 24. 24 is compared with 70. 24 is compared with 70. So 24 is not equal to 70. So the condition fails here. Now it will move towards the next position. The next value is 23. 23 equals to 70. Condition is not true. 23 is not equal to 70. Now the search value will move towards its next position. 21 equal to 70. 21 equals to 70, condition false. Again, it will move towards one position, towards right. So what it is doing, every time it is, if the search element is not matched with the given index value, so we will move towards one position towards right. And it will compare. It is 20 equal to 70. 20 equal to 70, false. Next element in the list is 18. 18 equal to 17. No, false. Again, 4 equal to 70. False. 3 equal to 70. False. Now it is 70. 70 equal to 70. So here 70 is the element that is at its index position 7. And this 70 is the key value. What we are doing? We are taking the key value. This is your key value. You are searching with the key value with the element in the all the elements in the array. Yes, 70 equal to 70. Condition is true. Element found at the location where we got that element at the index 7. So this it should return. Where you got that element, that index position, it should return. So we got that element at the index position. So if we have to write a program for this one, how you will write? So first you need to declare the array. So that array is this one. We need to declare the array. So here the declaration of array was done. Int a of 100. And how many number of elements you will enter in the array, that we will take it in runtime. So it is n. Int a of 100, comma, n, comma, I, comma, key, comma, flag equal to 0. So what is flag? I'll tell you. Flag is nothing but it's a positive integer and it is associated with two values. Either 0 or 1. Means true means 1, false means 0. So flag is a positive integer that is associated with two values. One is 0 and another one is false. So initially flag is set to 0. So here in the first line, hash include stdio.h int main. Okay, execution of your program starts from the main section. Int a of 100. So what type of declaration is done? This is array declaration and that is static memory allocation is done here at the time of execution, like compile time. You will fix the size of the memory. It's a of 100. 100 is the array declaration and n. So even though you have declared here 100 means suppose 100 into 4. 400 bytes of memory is allocated for this array declaration, but we are not using that number of elements in the array. Here see 0 to 10. So total number of elements in the array are only 11 here. In this case, array index starts from 0 and ends at 10. So 0 to 10 total number of elements are only 11 in this case. So to enter 11 values, you can take it through runtime. So scanf, enter the number of elements in the array. Here, number of elements. So 11 as because the total number of elements I have taken here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So only 11 elements that I'll read it in runtime as the input. Scanf %d, comma, address of n. Next printf, enter the values. So how to enter the values in the array? We need a for loop. We need a for loop to enter the values in the array. So what is how you will enter the values? By using the for loop. Why? Because it's an array and array is the index positions starts from 0. So I'll write it clearly here. For I is equals to 0, I less than n, I plus plus. How to give the input? Through the scanf function you will give the input. Scanf %d, comma, address of a of I. Okay, address of a of I. So now we'll see this. For I is equals to 0, 0 less than, what is the n value? The total number of elements we have taken here as 11. Okay, 0 less than 11. Condition true. Now control will enter inside the loop. Scanf %d, comma, address of a of 0. What is address of a of 0? Which function we are using here? Scanf function. That means what we are telling? Insert a value or give the input at the index position a of 0. So at a of 0, this one, at a of 0, what input I gave earlier? Here randomly we have taken some values, right? It's 24. You can enter 24. So now you are giving the input 24. Next, I plus plus, I becomes 1, 1 less than 11, condition true. Scanf %d, comma, address of a of I. Address of a of I value is 1. A of 1. Value at a of 1 is 23. Next, I plus plus, again I gets incremented, I becomes now 2. 2 less than 11, condition true. 2 less than 11, condition true. Scanf percentile d comma address of a of 2. Address of a of 2, that is 21. So here at a of 2 position, at index position 2, the value at position 2 is 21. Next I becomes 3. 3 less than 11 at a of 3. A of 3 value is 20. This is an array name. Name of the array is A. The index position is at 3. So now we are giving input at that position, at index position 3. It's A of 3, that is 20. The value that is at the position 3 is 20. Next I plus plus, I becomes 4. 4 less than 11, condition true. Scanf percentile d comma address of a of 4. What is the value at a of 4? That is 18. Next 5 less than 11, condition true. At a of 5, value at a of 5 is 4. Next 6 less than 11, condition true. At a of 6, value at a of 6 is what? 3. Next same like this you will enter at 7. 7 less than 11, at 7th position I have inserted the value 70. Next 8. 8 less than 11, condition true. At 8th position you will enter the value. Whatever you want to enter, you can enter, because it's all user choice, right? So it's 56. Next 9 less than 11, condition true. A of 9, at 9th position you can enter the value 12. Next 10 less than 11, condition true. At a of 10, at a of 10 the value is 8. Next 11 less than, again increment. 11 less than 11, condition is false, so exit. This step is to enter the values in the array. So now what we have done after entering the values in the array, what we have done in the previous example, we have taken an array and after that we have taken the key value. With that key value we check whether that element is in the list or not. So first you need to enter the key value. Okay, so key value should be given as the input. In the previous case, which key value we have taken? We have taken the key value as 70. Key is equals to 70. So the same thing I am taking here. So that key value must be given as the input. So printf enter the element to be searched. That element to be searched, will take it as a key value. So scanf percentile d comma address of key. As key is an integer value. Okay, it is an integer value. The format specifier is again percentile d to represent this one. So key is a variable. Key is a variable here. Key is a variable. We have declared that variable. And that value is treated as an integer value. So you have to use the format specifier percentile d. Next, what condition we have taken to check whether the value is present in the array or not. So what we have done? We have taken a key value. That key value is 70. And what we have done in the previous example, with every element in the list, it starts compare with each and every element in the list. Like suppose the index position is at 0 is 24. 24 is compared with 70. So the condition is not satisfied. 24 not equal to 70. So next the control moves to the, or else it goes to the second position and check the value that is at the index position 1. So you can write the condition like this. If key equal to where we have checked that value in the array. So array is a of I. If key is equals to a of I, now we'll take the flag bit to 1. Flag bit is set to 1 and break. Why we have taken break, I'll tell you. So we need a for loop here because we are checking in the array. For I is equals to 0, I less than n, I plus plus, break. If flag equal to 1, printf the number is found at the location. Okay, so let's see. 70 equal to, so We need a for loop because we are checking in the array. For I equal to 0, for I equal to 0, 0 less than, what is the value of n? Because the total number of elements in the array we have taken are 11. So it is 11 again. In the previous case, while entering the values, the n value is same because we have taken the n is number of elements you can take based on your choice. If you want to search only the small array list, you can take 5. So here we have taken 11. So I am taking the n value as 11. 0 less than 11. Condition true. Control will now enter into the for loop, the body of the for loop. It is key 70 equal to a of 0. What is a of 0 value? 24. 70 equal to 24. Condition false. So flag is not set to 1. Initially flag is set to 0. Now still flag bit is 0 only. Next I plus I becomes 1. 70 equal to a of 1. What is a of 1 value? 23. 70 a of 1 is 23. 70 equal to 23. False. Control will not enter inside the if condition. Next I plus again. I becomes 2. 2 less than 11. Condition true. A of 2. What is the value that is at a of 2? 21. 70 equal to 21. False. Again I increments. I becomes now 3. 3 less than 11. Condition true. Key is still 70. Key is always the same. Key value will not change because the key value is only the one input which we give. In this case, my key value is 70. A of 3. What is the value at a of 3? 20. 70 equal to 20. False. Next, I gets updated. 4 less than 11. At a of 4. What is the value at a of 4? The value at a of 4 is 18. 70 equal to 18. Condition false. Next, I gets updated. I becomes 5. At a of 5. What is the value at a of 5? Which is 4. 70 equal to 4. Condition false. Next, I becomes 6. 6 less than 11. Condition true. At a of 6. What is the value at a of 6? 3. 70 equal to 3. Condition false. Now again I value gets updated. I becomes now 7. 7 less than 11. Condition true. Now control will enter inside a of 7. I value is now 7. Initially I is 0. Next I is 1. I is 2. I is 3. I is 4. I 5. Now I has become 7. At a of 7. What is the value at a of 7? 70. So here you got the value. 70 equal to 70. Condition is true here. 70 equal to 70. Condition true. Now control will enter inside the if condition. So it is if condition. The true block statements will execute. So what is here? Now flag is set to 1. Flag is initially 0. As I told, flag is a positive integer which is associated with two values, either 0 or 1. So now flag is set to 1. And break. Why we have written break? Because what is break? Whenever the statement encounters here, like we got 70 here, suppose you have another 70 here. Okay, so it should stop until you find the key value in the first position. The loop should not repeat. It should end up there. So I don't want the another 70 to print here. So I want only one value that at the location. Okay, so here flag is set to 1 and break. So what is the next line written here? If flag equal to 1. So if you found that element at that particular position, what we should get? We should get where we got that element index value. So here 70 is at the index position. At index position 7. So the same. If flag equal to 1, what is now the value of flag? Initially flag is 0. Now flag is 1. 1 equal to 1. Condition true. Number found at the location %d comma I. Because we are representing the index positions with I. So now here you will get the output, you will get number found at the location. So in this example, number found at location 7. So like this you will get number found at the location. Suppose you take any random number which is not in the list, like 88, which we have not taken in the list. In this list we don't have 88. So what it will print? Suppose 88, until the end of the list you have traversed. So but you didn't get that element 88 in the list. So obviously flag bit will be 0, 0 equal to 1, condition false. So if this is if, so else block statement will execute, number not found. So in this example, see, enter here the screenshot after execution, enter the number of elements 5, enter the values 1, 2, 3, 4 and 6 are the values that were entered. So what is the size of the array here? The size of the array is, we have taken only the 5 values. The elements of the array are 1, 2, 3, 4 and 6. So enter the elements to be searched. What is the key value we have taken here? The key value I have taken here is 3. Okay. Enter the element to be searched. So this is your size of the array. This is your size of the array. Means you are telling my array size is only 5 and it is asking enter the values. Then how you will enter these values? So we have entered here 1, 2, 3, 4 and 6. In this example, we have entered here 1, 2, 3, 4 and 6. So what is the key value I have taken? Key value I have taken in this example is 3. Key value I have taken in this example is 3. So obviously by seeing this you can tell the key value is at the index position 2. Key value is at the index position 2. So this is what linear search. If the list goes like this, you have to compare each and every element in the list with your key value. So now what are the pros in this linear search? It's simple to implement and understand. It's very easy to implement and understand. Why? Because you have the key value and you will take that key value and you will search that key value with the element in the list. It's very easy to implement and understand also. No need of sorted data. Yes, one thing here it is, you no need to sort your array. It can be of any order. Like see this example, in the previous example we have taken 23, 24, 21, 20, like that we have taken. The list is not in the sorted order. Some random numbers I have taken. Like that your list can be of any order. Works on unsorted lists. Okay, the same. Works on the unsorted list. No need of the list to be in the sorted order. In place of searching, requiring no extra memory. Okay, so requiring no extra memory. With that memory only you can accommodate. Next, what are these disadvantages? Insufficient for large data sets due to order of n time complexity. You have to search for each and every element in the list. If the list contains of 100 elements, you have to search, and if your element is at the 98 position, you have to search until till that 98. If you reaches to till 98. Slow compared to more advanced searching algorithms like binary search, especially in the larger lists. So it is very slow compared to binary search. This algorithm is very slow because you have to take each and every element in the list to compare, and especially in the larger lists. So these are the advantages and disadvantages of linear search. In the next session, I am going to discuss what is binary search and the algorithm and example program also. That's all for this session. Thank you.